I'm going to show how to use the rounding functions in Affinity Photo's procedural texture filter. Now I usually use fraction when I want to get a repeating coordinate system, and one of the problems with that is you can get these negative numbers where it doesn't follow the same pattern, and I often get asked, how do I get rid of that? I'm going to show how to get rid of that, but I also thought it would be a good opportunity to go over the different rounding functions available in the procedural texture filter. In this video, I'm going to look at the following rounding functions: round down, round up, round, truncate, and fraction. Now there's also a couple of duplicate functions, so round down and floor do the same thing. Round up and ceiling do the same thing. And truncate has an abbreviated version called trunc, and there's another thing called whole. And so I'm going to look at those and do a comparison of those functions, and then look at how that applies to creating a repeating coordinate system grid. First of all, I'm going to look at the number 0.25. If I round that down, or take the floor of it, that goes down to 0. The next function is round up or ceiling, and so in this case you're going to round up to the next whole number, and this is 0.25, so the whole number above that is 1. Then there's rounding, and so this is like our more typical rounding we might do in math or statistics, or when you're making a measurement. You're going to round to the nearest whole number. So it's 0.25, and so we're going to round that down. If we're above 0.5, we'd round it up. So 0.25 rounds down to 0. Now truncate means to throw away the fractional part of the number. Whole means to just include the whole number part of the number. In either case, that's 0, and so if you truncate or take the whole number part of 0.25, in both cases you get 0. And then the last function here is the fraction function, and in that case you just throw away the whole number part of the number and just take the fractional part. So that's 0.25, so it doesn't change in this case. Okay, now I'm going to look at the next one, 0.75. Rounded down is 0. Rounded up, it goes up to 1. And then rounding 0.75, you round it up this time. Truncated is 0, because we're just throwing away the fractional part of the number. The fractional part of this is 0.75. Okay, I'm always curious how they handle 0.5 when it's just in the middle. So rounded down, it is 0. Round up, it's 1. And when you round it, they chose to go with 1, which is fine. Truncated, it's 0. Then the fractional part of it is 0.5. So far that should be what you would expect. Now we go to look at the negative numbers. The first one I'm doing is negative 0.25. So rounded down, that goes down to the first whole number less than negative 0.25, which is negative 1. When you round it up, you round up to the first whole number that's larger than negative 0.25, so it rounds up to 0. When you round it off, or just do a round, that goes to 0. Then if you take the whole number part of this, you throw away the fraction and just look at the 0. So that goes to 0. And then the fractional part of this is negative 0.25. So they don't just take the fractional part, they take the sign and the fractional part of the number. Next is negative 0.75, rounded down, goes down to negative 1. The ceiling, which is rounded up, it goes up to 0. Rounding, it goes to negative 1. The whole number part of that is still 0, and the fractional part is negative 0.75. Okay, and then negative 0.5, rounded down is -1, rounded up is 0, and rounded off is -1. So they round it to the down in this case. So the other one at positive 0.5, they round it up. At negative 0.5, they're rounding down. Truncated is 0. Okay, and then the fractional part is negative 0.5. Next, just to check on this, I'll do 1.5. So the rounded down is 1. The rounded up, you go up to 2. Rounding, you go up to the next, they go up to the next whole number, which is 2. The whole number part of it is 1. And the fractional part of this is 0.5. And then at negative 1.5, rounded down, you go down to -2. Rounding up, you go up to -1. Rounding, you go to -2. The whole number part, or the truncated version, is -1. And then the fractional part of it is -0.5. Okay, so those are some examples that sort of get into the guts of how this actually works. I'm going to look at how this works with a coordinate system as an example. So I'm going to start with a new document, and I'm going to choose XGA and make it 1024 by 1024 pixels. Make sure it's in RGB mode and create that. Fill it with black, and then add a live procedural texture filter. And I'm going to start by adding a single equation and assign it to all 3 channels. And I'm going to add a real number input A, label it scale, and set it to 4. And for my equation, I'm going to start with a variable v equals vec2 of rx ry times a divided by w. So there's my coordinate system. The origin is approximately in the middle of the screen. I guess probably exactly in the middle of the screen. You can see it's increasing. The red increases as I move to the right, and the green increases as I move down. What I usually do when I want to have a repeating pattern of coordinate systems is just take the fraction, the fractional part of v, like that. One interesting thing to notice is that fraction is a vector function. So given a vector, it returns a vector. So it returns this 2-element vector, and then it rounds it off. As I said before, it sort of eliminates the whole number part of it. But over in this area, it generates negative numbers. So when it's less than 0 in either the x or the y direction, it generates negative numbers. So I'm going to bring this up to 10 on the scale. Yeah, so you can see here it's repeating the coordinate systems, but over here, as it moves beyond the x-axis for the y component, it goes negative, and then when it moves beyond the y-axis for the x component, it goes negative. And so that's why you don't see any green up here, you don't see any red over here, and in this quadrant it's all black. There are ways to make these negative numbers basically go away. Let's start with round down, and usually I'll use the floor function. They do the same thing, and so I'm going to just take the floor of v. Okay, so there's the floor of v, and you can see it's just taking a whole number version of this grid. If I take v minus the floor of v, then I get a repeating grid pattern. And it just goes on forever, and I don't have any negative numbers in this. And the reason is that if I look at, say, a negative number like minus 0.5, and I take the floor of that, that will be minus 1. And if I take minus 0.5 minus -1, that goes to plus 0.5. So I'm taking a negative number and subtracting a larger negative number, and so I'll always have positive numbers. Now I could look at the ceiling. I'm just going to leave it in subtraction mode here. What if I change it to the ceiling of this? Okay, so if I change it to the ceiling, they're all negative numbers. Okay, so that didn't work. But if I take, so let's do ceiling minus V. Okay. Okay, so this looks okay, but one thing that happened here is the x-axis used to go increase as I move to the right. It isn't. It's increasing as I move to the left here. And then the y-axis used to increase as I move down. It's increasing as I go up. So I could flip this around by making both Rx and Ry negative over here, but I'm not going to do that. I just thought that was curious. Next one I'm going to do is I'm going to look at V minus the round of V. V minus round of V. Okay, so this one, it looks like it's oriented the correct way. X increases as you move to the right, Y increases as you move down. But the cool thing here is this is centered on the origin. So usually when I'm doing fraction, I have to subtract 0.5 to get it to do that. So if I take fraction of V, the origin is over here in the corner, the upper left corner, and I need to move that to the center. So I usually subtract off 0.5 and it comes to the center. But if I take and do instead V minus round of V, I get the origin in the center. Let's look at V and look at the whole number of that. Okay, so the whole number part, if you do it this way, it'll have these negative numbers, and then just to verify, if I use the truncate function, it's exactly the same. I'm going to show how to use the round function to get rid of the negative numbers in a repeating grid. I'm going to start with the variable v is 0 equals vec2, a two-element vector of rx and ry. And I'm going to multiply that by my scaling factor a and divide by the width of the document in pixels w. And so that looks like that. And as you can see, I have this dark corner up here. That's where the negative numbers are. Now, usually I would make another variable v equals the fraction of v0. And you can see it makes a repeating pattern down here. If I bring this up a little bit, I have the repeating pattern down here, but up here where I have the negative numbers, I have these sort of artifacts or defects. Now for this one, I'm going to set up a polar coordinate system. And so in order to do that, I'm going to set up another variable vp equals vec2 of a tangent 2 of v dot y comma v dot x. So that's my first component of the polar vector is the angle. And the second component will be the radius, which is the length of v. And I have to scale this because it returns a value between minus 180 degrees and 180 degrees. And so I'm going to divide that by 180. So it'll have a range from -1 to 1. So that looks like that. Now, I'd like to have these centered, so I'm going to subtract off a 0.5 from my fraction. Okay, so now all of my circles are centered down here, and I'm just going to drag this up, so that's what I usually do. And now for my pattern, I'm going to just choose a very simple one, which is the oscillator of vp.x. Okay, and I'm actually going to make that 10 times. Okay, so there's my repeating pattern, but if I go up here, I don't have the same pattern. So if I double click and bring it to the center, I don't have the same pattern. So I'd like the same pattern no matter how I position this. So I'm going to add a new equation, and I'm going to copy this one and paste it down here so I can keep track of what I did to it. Alright, I'm going to assign this one the RGB channels. Instead of fraction of V0 minus 0.5, I'm going to put in V0 minus round of V0. And there, now it's the same pattern no matter where I move this. Alright, let me know if you have any comments or questions, and thanks for watching.